So last Friday, we talked about properties of rational exponents. This is going to be a quick review to make sure you understood, you remember. And the properties are the same properties of exponents. The difference is that m and n now are going to be fractions. They are going to be rational expressions. Okay? So this is the only difference, because the properties are the same. We have seen on chapter 4. If you have a multiplication of like bases, you're going to add the exponents. If you have a division of like bases, you will subtract the exponents. And the power rule, if you have this situation, you're going to multiply, and the power of a product and power of a quotient, it kind of works like the distributive property. If you think you're going to distribute the exponent to the factors, or you're going to distribute the exponent to the numerator and denominator. Here at the bottom, if you check at the bottom, you're going to see there are also the properties of negative exponents. If you have a negative exponent, you can rewrite as you flip, it's going to be 1 over a, and then you're going to use the positive exponent m, and also 0. If you have a to the power of 0, if a is different from 0, right? A different from 0, submitted to the power of 0 equals to 1. This is another property that you're going to remember, you're going to apply. Now, I want to check with you if you remember those examples. You remember how to work it out, how to solve it. And it's halfway. If you check, there's the question, and then the answer is worked here in the red, and you just have to finish the answer with the number. I will ask 2 students to send me a message and give me the answers. For letter A, we have this is equals 12, and you have to add the exponents, right? Remember the properties of exponents we've seen before. You have to add 1 over 6 plus 5 over 6 is 6 over 6. This is equals 12. Exponent 1, this is equals 12. That's the right answer, 12. Thank you, Jonathan. And Jonathan, yes, that's right, perfect. For letter B, I'm so happy. That means you remember. Yes, 5 exponent 1 over 3, and then you have to multiply, and it becomes 3 over 3 times 7. And this becomes also 3 over 3. This is 5 times 7 equals 35. Perfect. Perfect. Thank you, Jonathan. Thank you, Jonah Lee. And let me show the last one. The last one, you have 2 exponent 1 over 3 times 6 times 4 to the power of 1 over 3 times 6. So 2, 6 over 3 times 4, 6 over 3, and this is equals to 2 squared times 4 squared. This is 4 times 16, 64. Great, I'm so happy because you remember, you know how to solve it. Yes, apply the properties of exponents, simplify, and you're going to find the answer. Great. If you're still confused about it, you just need to practice a little bit. You can use these examples. You can find more examples on the internet. You can find more examples on your quizzes. You can ask me for more examples to work, more extra work. As long as you practice, you will be able to remember and how to apply these properties. Thank you, Jonathan. Thank you, Jonah Lee. Great. Thank you very, very much. That's perfect. Now, we will work on a new topic. Is the multiplication property of radicals. Usually I don't like to read this explanation. I like to go straight to the example. But let's read real quick just the box. The property of multiplication of radicals. Let A and B represent real numbers such that nth root of A and nth root of b are both real, then you're going to have this property, nth root of a times b equals to nth root of a times nth root of b. That's it. This is the property. You can also write, let me show here at the bottom, you can flip, you can switch sides. It's going to be the same thing. Nth root of a times nth root of b equals nth root of a times b. Sometimes, to simplify an expression, you're going to use this way, and other times you're going to need to use that way. Okay, both ways are correct, but sometimes you're going to use you will need to use one way, or you will need to use another way. Great. Let me show a few simple examples. Check this. Let's say we have the square root of 144, and you know that square root of 144 is 12. But let's suppose you don't know, you're confused, you don't remember, you don't know that square root of 144 is 12. But you know that 144 is 16 times what? 16 times 9. Let me write different. You know that 144 is 16 times 9, right? And you can break it down, you can write as square root of 16 times square root of 9. And you remember that square root of 16 equals to 4, and also you know that square root of 9 is 3. That means 12. Square root of 144 equals 12. Right? This is one application. Let's check the reverse process, the other way around. If you have a square root of 3 times a square root of 12, can you simplify? Well, the square root of 3 is not a perfect square, so you cannot simplify just a square root of 3. And 12 is not a perfect square as well. You cannot simplify square root of 12. You can simplify a little bit, but not completely. But you can write this as 3 times 12, square root of 3 times 12. Okay? And this is square root. Oops. Just a minute. The square root of 36, and now you know square root of 36 equals 6, and this is the answer. Yes, now you can simplify and find just one integer number, because the result was a perfect square. Okay, now let's check another example, because we are working only with numbers. Now let's check another example with variables. And we have the example, letter A. Fourth root of b exponent 7, okay? And this example now, we are working with a variable. I think it's easier when you have just variables. It's easier because you're going to write, there's a step-by-step. Let me show how it works. You're going to write here b outside the root. Then you're going to write the fourth root and another b. Okay? You start by doing this. And now just write these boxes here, because those are the exponents that we will fill in. You're going to calculate and fill in with the exponents, right? So get the original exponent 7. You're going to divide by the index 4. 7 divided by 4 is 1. 1 times 4, 7. 1 times 4, 4. And the remainder is 3, right? To get to 7, the remainder is 3. Write the result on this box outside the root, and write the remainder on the box inside the root. And that's going to be your answer. See? The answer is B, exponent 1 to the power of 1, but we don't need to write 1. 4th root of B cubed. This is how you simplify and you're going to apply the multiplication property when you have variables. I think it's easier because you just have to work this step by step. You don't need to break down, you don't need to factor out, you just need to do this step by step and find the results. Okay? Now, tell me, do you have questions, any questions at all about the first examples with numbers, the second example with variables? And I'm not going to work this next example because I want to save time to work with you on the quiz. Okay, so the letter B, I'm not going to solve now. If you want, you have the solution here on the slides. But I want to save time and work with you on the quiz. Any questions, any comments, any feedback? If you're happy, we can move on and practice. Go to the quiz. You agree? Well, if you all agree, before, let's try the bell work. Now send me your messages. Tell me what is the answer. What are the square roots of? And then you have square root of 81 equals question mark. That is the question. It looks simple. Sometimes the questions that are too simple, they have a trick. This one may have some kind of a trick. Okay? So send me your messages. Tell me what are your answers. Okay? So the question is asking the square root of the square root of 81. So you have to apply the square root twice. Is the square root of square root of 81. And you also need to find both square roots, the positive and the negative square roots. So this is going to be the positive and negative square roots. Square root of 81 is 9. So this is positive and negative 3. The answers are negative 3 and positive 3. Those are the answers. This is a tricky question. And you found the answer halfway. Most of you answer 9. This is just halfway. You have to complete because the question is asking the square roots of the square root of 81. Okay? That is a tricky question. That is just a game. So you can remember some concepts and you can warm up to work on the quiz next. All right? So thank you, Kiara. Thank you, John Lee. Thank you. So the answer is negative 3 and 3. Moving on to our quiz now. Today we have to simplify and write the answers as radical expressions, not decimals. Let's work on the first one, letter A. And this is going to be kind of simple because we work on the example. This is square root of 3 times square root of 12. We can write the square root of 3 times 12, right? This is square root of 36. And now we know square root of 36 is 6. That's it. This is the right answer. 6. Now, letter E. Just let me show, it's slightly different because 28, square root of 28, 28 is not a perfect square. We cannot find an integer, right, as the result here. So the question is asking you to find a rational expression, the simplest rational expression. We need to break it down, and we have to understand that 28 we can write as 4 times 7. Well, we can write as 2 times 14, and we can you can write as 2 times 2 times 7. But we need to find one perfect square to simplify. And the perfect square that we just have is 4. So we can write as square root of 4 times square root of 7 to square root of 7. Is going to be the answer. Okay? So when you simplify, you will break the number down and try to find at least one number that is a perfect square that you can simplify with the roots that you have. Now give me 1 minute. I will check attendance and then I will get back. We can work on more questions together, okay? Just give me 1 minute. Let me show letter T. Letter T, it looks like this one, letter S, with different variables. So you have to write negative, keep the negative signs, write P and Q, the fourth root, and write also P and Q inside the root. Leave some space for the exponents. You have exponents here and there. For P, P is the original exponent is 16. You have to divide by the index 4. So 16 divided by 4, 4. 4 times 4, 16. The remainder is 0. Outside the root, you're going to write the result. Inside the root, you'll write the remainder. Okay? Now for Q. For Q, you have 17 divided by 4 is going to be 4 as well. 4 times 4, 16. The remainder is 1. So here you have 4. And inside the root, you have the remainder 1. The answer is going to be negative P to the 4th, Q to the 4th, and 4th root P to the power 0, 1, Q to the power 1, just Q. Okay, thank you, Chiara. Yes, thank you, Chiara. Let me show everything that we worked so far. Zoom out. If you have more questions, just let me know. We still have 1 minute, just one last minute.